My name is Pete Dumont. I'm President and CEO of the Air Traffic Control Association. I'm here to talk to you about machine learning and artificial intelligence today, and how we can use it in aviation, and is aviation ready for it in the control environment and in the control room. As you can see from the parentheses on the slide, it says, spoiler alert, we're not ready. And I don't believe we are ready, which doesn't mean that we can't get there, doesn't mean that AI doesn't have uses, doesn't mean we're not using it in some places already. What it means is we have to ensure that as we introduce AI into the operational environment, we do it with a measured, moderate, and safe approach. Because when we fail in aviation, we fail publicly and we fail catastrophically. So when we talk about AI, what are we actually talking about? So what's the definition? No one really agrees on the definition. The term was coined in 1956 by John McCarthy at Dartmouth University. And since then, AI has had its dips and it's had its peaks in the way it was accepted and the way it was used in society. In 1956, it took a whole room full of computers to do the simplest of calculations and computing jobs. Now, you can basically do those same jobs on your iPhone. So what we've done is, as technology's increased, as we've had chipsets like NVIDIA that have tremendous computing power and are the leaders in AI, we've seen the capabilities of AI being introduced into our lives and into aviation. So, but I want to make one thing clear. When we're talking about AI, we're not talking about automation. So when we talk about things like automation, we're talking about things like autopilot in an aircraft. So an autopilot in an aircraft is programmed with certain parameters to do certain tasks. It takes the model of the aircraft and it figures out how to fly the aircraft based on that model and the performance characteristics of that aircraft. NASA did an experiment called Learn to Fly. And what they did is they took a remote control aircraft and they put it in the air and they had put it into turbulence, and they had the autopilot take over to try to level the aircraft. The aircraft was porpoising. The autopilot couldn't figure it out and couldn't get the aircraft under control. They then let pilots do it remotely. The pilots couldn't get it under control. Once they introduced AI into the system and they didn't model the AI after the aircraft, what they did is, which is amazing, they took what they wanted the aircraft to do and how the aircraft works. They taught it pitch, roll, and yaw, and they told it level off the aircraft. 3 to 5 seconds, the aircraft was level and flying in turbulence. That's AI learning how to do something based on the input it's taking. It could have prevented maybe things like Air France, where the pilots were getting bad information and then making decisions based on that information. But they were using knowledge based on what the parameters of the aircraft was instead of what they wanted the aircraft to do. So again, a little bit more about what's AI. So AI is the encompassing sphere we're talking about here, which also has machine learning and deep learning in it, as you can see, and you can see the definitions of that. So we use AI in our lives every single day. You can see it from the examples here on the slide, but you can draw from your own experiences. If you have Alexa in your house, or Google in your house, or Siri on your phone, you're using artificial intelligence. Those are the voice recognition tools, and what they do is they talk to the computers, and the computers contain the artificial intelligence, and they make decisions and recommendations based on your input, your queries. Same thing happens with Netflix. So if you keep asking Alexa about different things you want to buy, Alexa is learning about the things that interest you. So when you go to Amazon Prime, or if you ask Alexa, it will make a recommendation of things you might want to buy, with the ultimate goal of knowing what you want to buy before you know you want to buy it, which that's a little scary. And when we talk about AI, we think about some scary things like 2001: A Space Odyssey, HAL, Skynet, and Terminator. And although those seem kind of far-fetched because they're movies, there are people that are seriously concerned about artificial intelligence taking over for human intelligence and controlling its own environment. But That's a completely different subject, and we could go into that for hours. It's also used in aviation now. You see it in the examples that are on the slide here. You see it in preventive maintenance and maintenance in general of aircraft. So what AI does is it can look at a part, and it's been told by image recognition what the part should look like brand new. And then it compares it to what the part looks like now, and it figures out the part is worn down a certain amount, and it can predict a failure point in time, or it can tell you how worn the part is and what you can expect to do. And that helps you prevent a failure before you do the maintenance, which is very beneficial. So what are our goals here today? What we want to do is we want to talk about how to get AI into the cockpit, how to get it into the control environment, and what are we going to use it for? We're going to use it to increase efficiency, safety, load on the human being, so the human being has less to think about and less to do, concentrate on flying instead of on the things that the computer could do for them. So the challenges of introducing artificial intelligence into the operational environment. One of the main challenges that I see and that I'm concerned about is if you take artificial intelligence and you put it into a control environment, the way artificial intelligence works is it learns. And as it learns, it modifies its code. So you tell artificial intelligence you want it to do this inside the aircraft, and you put it inside the aircraft, and you put it inside multiple aircraft. And based on the parameters that were set for it to learn, it will learn different things. And different AI in different aircraft will learn different things. So when we certify an aircraft or a system to go in an aircraft or a system to go into air traffic control or ATM environment, what we do is we verify it and we validate it. Does it perform the same way every time? Does it perform the task it's supposed to perform? And do we understand how it does it? Because as soon as we put it into the aircraft, we have to ensure and be confident that it's always going to do it the same way. Artificial intelligence doesn't work that way. Artificial intelligence takes input, and we have to determine where we're going to get that input from. Is it going to be input that we get from reliable sources that are good for flying an airplane? Or is it going to be from, for example, the internet on sites that are unreliable, untrue, conjecture, and people that, quite frankly, don't know what they're talking about, and put out papers that artificial intelligence can look at, read, and make decisions on? So that's a exaggeration for point. But the fact that artificial intelligence, once it's in an aircraft, can change its initial programming means how can we validate it and verify it? The minute it changes one iota of code, it's no longer verified and validated. We no longer know what it's going to do. And we've seen this happen in experiments in real life situations. NASA has had experiments where they programmed AI to do a certain task, and it did the task, got better at it, and they wanted to know why. So they examined the code. The code has changed. They didn't know how the code had changed. That's the problem. If we don't understand it well enough to know what it's going to do, then we can't put it in an aircraft that has passengers at this point in time. Now, a lot of people say there's a solution, which is called bounding. So with bounding, you use the artificial intelligence to get to a certain point of efficiency in the testing phase. Then you bound it. You don't let it learn anymore, and you don't let it change. And then you take that and you put it into the aircraft. Well, that's all fine and good, but we haven't put AI in the aircraft, have we? We haven't increased the efficiency of the flight environment. We've just increased the efficiency of how we produce the part that we put in the aircraft. So that's the main challenge that I see here of introducing artificial intelligence into the cockpit or the control environment. Now, in the control environment, controllers could use it and do use it for weather prediction, for example. We could use it for things like recommending the most efficient route the best time to fly an aircraft, and then working collaboratively with pilots to determine how we do that, when we do that. But the difference there between letting the AI make the decision is the human still makes the decision based on the information it gets from the computer. So do I think we're ready for artificial intelligence in the control environment? I do not. I think we can get there, and I think we have challenges to solve, and I think some of the smartest people around are working on those challenges. NASA has some very interesting programs going on. DARPA has some very interesting programs going on as far as artificial intelligence is concerned, especially with things like you just heard about, spectrum management. Artificial intelligence is now helping with spectrum management in a dynamic environment. When one spectrum isn't being used, automatically switch to that spectrum to use that spectrum for whatever the task is, instead of defined, layered, segregated spectrum layers. So I think AI is very, very interesting, and I wish we had more time to talk about it, but we're just about out of time here. So I'd just like to leave you with one thought, that artificial intelligence has unlimited possibilities. And as we see new business models being developed and new entrants into the airspace, artificial intelligence is going to make a stronger and stronger push to get into the control environment. I think we'll get there. I just don't think we're there yet. So again, I'd like to thank RTCA. I'd like to thank Terry, and thanks for listening. Have a good day.